Hello everyone, now we have to discuss the concept of nodal analysis. Previously we had a discussion about the mesh analysis, it is the application of KVL and in that we are developing a loop equations, but here we are developing what? Nodal equations. With respect to KCL, we are developing a nodal equations. By solving those nodal equations, we are going to get that corresponding voltage values of that respective nodes. So, before going to the problems, first we have to see the definition of nodal analysis. So, what is nodal analysis? Means it is a method that provides a general procedure for analyzing the circuit using node voltages as the circuit variables. In case of mesh analysis, we have to analyze the circuit by varying the circuit current. Though circuit current is nothing but variable element, so variable parameter in that circuit. Here node voltage is nothing but variable parameter. Then nodal analysis is the application of KCL. In case of mesh analysis, it is the application of KVL, it is the application of KCL. If we have n number of nodes, then the number of nodal equations should be n minus 1. For example, if you consider this circuit, see, if we consider this, we have how many nodes? 1, 2 and 3. Means this is 1, but this total should be taken as a reference. Why? Because there is no branch, resistance branch in this any branch. In this branch, there is no branch in any of that circuit, that is one of the node. So, the number of nodal equations should be this is 1, this is 2, should be equals to from this 2 n minus 1, no, that is 3 minus 1, 1 2 3. So, 3 minus 1. Okay. Then the types of nodes, non-reference node which acts as a definite node voltage, means there is a value of that voltage source. For example, this is 10 volts, say this is nothing but value of that non-reference node, simple. This is one branch, for example. So, this is one node, no? This is one node, that is nothing but non-reference node, which is having what? Some definite value of the voltage. Okay? This is non-reference node. For example, this is 10 volts. Now, a reference node which acts as a reference point to all other nodes is nothing but, example is nothing but 8th node, that is means this is nothing but 8th node, this is nothing but reference node for this non-reference nodes. Okay. 1 and 2 are, these two are non-reference node and this one is reference node. So, from the circuit 1 and 2 are non-reference nodes because these two nodes are having a definite voltage, but this is having 0 voltage, 8th node, that is 0 voltage. And coming to one node point, if there is a voltage source between non-reference node and reference node, that is this is what? This is non-reference and this is the reference node. Okay. If there is a voltage source between non-reference and reference node, then the corresponding voltage source value should be treated as non-reference node value. See, consider this. If there is a voltage source present between non-reference and reference node, then we have to consider the non-reference node value should be is equals to the voltage source value. Here the non-reference node value equals to what? 10 volts. That is the point. If there is a voltage source between non-reference node and reference node, then the corresponding voltage source value should be treated as the value of that non-reference node. Okay. Why? Because there is no drop, no. If there is a drop, here the voltage should not be equals to 10, because here there is no voltage drop. Then only it should be the value of non-reference node. If there is a resistance branch, obviously the same amount of voltage cannot be applicable to this node, because some voltage drop is there, no. So, this 10 volts minus the voltage drop should be equals to this non-reference node voltage. Okay. There is no branch resistance, obviously this should be treated as a non-reference node. If there is a branch resistance, this should not be equals to the voltage of that non-reference node. This is very important point. Okay. Now, we have to discuss the problems of nodal analysis. So, this is the first problem and this is the circuit. From this, we have to calculate the current through the 4 ohm branch resistance. We have 1 ohm, 2 ohms, 4 ohms, 2 ohms, 1 ohm. But the examiner wants what? The current through that 4 ohm branch resistance by using nodal analysis. Okay. Then solution. So, in this nodal analysis is nothing but application of KCL, no, means we are developing current equations. So, based upon that KCL, we are developing a current equations. By solving those current equations, we will get the corresponding current value of this branch. For this, in case of mesh analysis, we are assuming a clockwise direction of that different loop currents. If examiner does not provide any loop current direction, we are assuming our own direction. Same pattern should be applicable in this case, but here we are assuming our own current direction at that particular node. Okay. Then so, this is the circuit diagram given, that is 10 volts, this is 5 and this is 1 ohm, this is 4 ohm, this is 1 ohm, this is 2 ohm, this is 2 ohm. So, this should be a node A, okay. This should be a node B, and this is what? This node and this node and what 2, 3, 4, 5 up to these all are comes under same node, okay, because there is no voltage drop through this branch. So, shown in this line, that is this is the reference node. Okay. If it is given like this, no problem. If it is not given like this, no problem. It should be treated as a reference node only connected to earth, that is the meaning. Okay. So, we have to assume our current direction, but I am assuming my own current direction in this nodal analysis, that is from this node the current is leaving, from this node the current is leaving, from this node the current is leaving. This is my assumption, and coming to this node, from this node the current is leaving, from this node the current is leaving, from this node the current is leaving. This is my assumption. For example, if you assume your own current direction, you will take towards, your wish, no problem at all. Okay, but my assumption is like this: the summation of all currents at that particular node should be equals to 0. I am considering the current direction should be out of that node. Okay, leaving, from this node leaving through these branches. Okay, clear. If, for example, if the examiner provides the current direction for this branch like this, So, except this branch you have to assume your current direction for the remaining two branches. Okay. If he provides the proper current direction, go with that direction, otherwise assume your own current direction. Okay. Leave it. So, now we have to solve at node A. At node A by KCL. By KCL, at node A is what? This should be, for example, I1, this is I2, this is I3, this is I4, this is I5 and this is I6. Okay. At node A, the summation of currents entering or leaving at a particular node is equals to 0, but here I1 is leaving, I2 is leaving, I3 is leaving. So, the summation of those three currents should be equals to 0 at that particular node. I1 plus I2 plus I3 is equals to 0. So, from this I1 is what? I1 is what? That is the potential difference of this node and this voltage source by the value of resistance. Potential difference of two voltages by resistance is nothing but current, no? So, like this, the voltage at this particular node, we do not know the exact value of voltage, because there is a resistance between this voltage source and this node. If there is no voltage source, obviously this 10 volts should be applicable to this node. Clear? I think you got my point. If there is no resistance here, for example, if it is like this, the voltage of this node should be equals to what? 10 volts only, because we have a node point, no? If there is a voltage source present between this non-reference node and reference node, this should be treated as the corresponding non-reference node value. But here the examiner provides a branch, okay, that is 1 ohm. That is why we are not going to get exactly 10 volts, some after 10 minus some drop, which is equals to the exact voltage of this nodal voltage. Okay. That is, this should be equals to VA, this should be equals to VB. So, I1 is what? Current direction is from VA to 10 volts, no? That is VA minus of, that is voltage difference of that nodal voltage VA minus of, see, the current should be entering from plus to minus. So, obviously, we are considering plus 10, that is minus 10 by what is the value of resistance 1 plus coming to I2. Here I2 is what? VA. What is this reference node? Should be equals to 0 volts, no? That is VA minus 0 by 2. VA minus 0 by 2 plus coming to I3, VA minus VB, means the current through this branch, 4 ohms branch, that is I3 from here to here, VA minus VB by 4, VA minus VB by 4 is equals to 0. Okay. From this, four VA minus 40 plus 2 VA plus VA minus VB is equals to 0. 4 VA plus 2 VA, 7 VA minus VB is equals to 40. Okay. At node A, this is the equation 1. Next, at node B, at node B, by KCL, I4 plus I5 plus I6 equals to 0. I4 plus I5 plus I6 is equals to 0. From this, I4 is what? VB, because see the current direction, it is from VB to VA. See, that is VB minus VA by 4. VB minus VA by 4 plus coming to I5. From VB minus 0 by 2. VB minus 0 by 2 ohms plus coming to I6, VB minus 5 by 1, because there is a resistance branch between this VB and this voltage source. If there is no resistance branch, obviously this VB should be equals to 5 volts. that is V B minus phi by 1, V minus phi by 1, which is equals to 0. Okay. From this, V B minus V A plus 2 V B plus 4 V B minus 20 is equals to 0. From this, 7 V A minus 7 V B, which is equals to minus 20, minus V A plus 7 V B minus 20 is equals to 0, that is V A minus 7 V B equals to minus 20. By solving those two equations, we are going to get, it should be multiplied with 2, should be multiplied with what? 7 V A should be 7. Therefore, 49 V A minus 7 V B is equals to 280. From this, V A minus 7 V B is equals to minus 20. So, from this minus plus, this is 48 V A, which is equals to 280 plus 20, 300. That is V A is what? 300 by 40, approximately it is 50. That is approximately we are going to get 6 point something, 6.1 volts. Okay. This is V A. So, coming to V B, from this 7 into, that is from this 1, 7 into 6.1 minus V B is equals to 40. From this 42.7 minus V B is equals to 40, V B is equals to what? 2.7 volts. V B is 2.7. So, we have to calculate the current through this 4 ohm branch, that is V A minus V B by 4 or V B minus V A by 4. Therefore, the current through 4 ohm branch is equals to what? V A minus V B by 4, V A minus V B by 4, which is equals to V B minus V A by 4, V A minus V B by 4, that is I 3 or I 4, V B minus V A by 4. The current through this branch is I 3, current through this branch is I 4. So, that is why this is I 3, which is equals to I 3 or V B minus V A by 4, which is equals to I 4. Therefore, I 3 is equals to what? V B is what? V A, 6.1 minus 2.7 by 4, which is equals to what? Approximately 3.4, sorry, 11 minus 4, that is 3.4 by 4, that is 0.8 amps I 3. From this, V B is what? I 4 equals to 2.7 minus 6.1 by 4, which is equals to I 4 is what? Minus 0.8 amps. So, at any case, we are going to get the same value. I 3 is 0.8, I 4 is minus 0.8, because this I 3 is like this, the direction is from A to B, I 4 is from B to A. Obviously, those two are opposite direction, no? That is why we will get negative sign. This is 0.8 towards V B, this is minus 0.8 towards V A. Those values are correct. See the magnitude, that is 0.8, 0.8. So, like this we have to calculate the current through any branch. The current through this branch I 5 is nothing but V B by 2. What is the value of V B? 2.7 by 2. Like this, the current through this branch V A by 2, that is 6.1 by 2. The current through this branch is what? V A minus 10 by 1, no? V A minus 10 by 1. We have V A value 6.1 minus 10 by 1. So, we have to get the current through any branch by using this nodal analysis. So, for this problem, the examiner provides, for example, the current direction is like this, okay, but he did not provide any direction towards this branch, in this branch, in this branch. We have two nodes, those are A and B, and we have to check is there any voltage drop between this voltage source and this reference node. Okay. For example, here see, we do not have any branch resistance, no, that is why from circuit VA should be equals to what? 10 volts, and check this voltage, node voltage B. VB should be equals to 5 voltage, that is at node A. This is at node B. So, finally, the current through this branch is nothing but VA minus VB by 2 or VB minus VA by 2. We have to check. It is better to write 3 ohms here. Okay. 1, 2, 3. The current through 1 ohm branch is equals to what? VA minus 0 by 1, VA minus 0 by 1, which is equals to 10 by 1, which is equals to 10 volts. So, like this, current through 2 ohm branch is equals to what? VA minus VB by 2 or VB minus VA by 2. If it is from A to B, VA minus VB by 2. If it is from B to A, VB minus VA by 2, which is equals to 10 minus 5 by 2, which is equals to, or you should write R minus 5 minus 10 by 2, which is equals to 5 volts, sorry, 2.5 or minus 2.5. Both are correct. So, then the current through this 3 ohms, the current through 3 ohm branch is equals to what? VB minus 0 by 3, VB minus 0 by 3, which is equals to VB is what? 5 volts, 5 by 3 volts, sorry, amps. So, like this we have to calculate the current through any branch.